This is part 4 of the Craftsman King Seeley 3-wheel bandsaw rebuild series. If you haven't seen part 3, click the link at the top of the screen. In this video, we're going to be taking a closer look at the Craftsman Slo-Speed converter attachment. We will also be polishing the column and cleaning up the table. Hello everyone, I'm Jeff and welcome to my shop. We got a lot to cover, so let's get to it. Craftsman first offered the Slo-Speed converter in 1954. It had a model number of 9-2342. Craftsman marketed this device as an easy to install and requiring no modification solution to someone who already had a bandsaw but wanted to be able to cut metal with that bandsaw. Most of the bandsaws sold by Craftsman were sold with 1725 RPM motors, and 1725 RPMs is too fast to cut most non-ferrous metals. This ingenious attachment would allow a reduction in speed with a 10-to-1 ratio, meaning that the RPMs could be slowed down to about 168 RPMs. And Craftsman would continue to sell these devices all the way until 1970. Just like all of Craftsman tools, Craftsman didn't actually manufacture this device. It was manufactured for Craftsman by a company called the Savage Manufacturing Company, which was located in Phoenix, Arizona. But this converter was not the first device sold by Craftsman that was designed and manufactured by the Savage Manufacturing Company. 1 year earlier, in 1953, Craftsman introduced the very slow speed attachment for its 15.5-inch Classic Craftsman drill press line. Similar to the multi-speed attachment that was invented and manufactured by Atlas, the very slow speed adjustment attachment utilized additional pulleys that provided for a wider range of speeds on a drill press. The ingenious design of the very slow and how it differed from the MSA is that you could adjust that speed with a handle on the drill press itself while it was running. So you didn't have to actually switch belts or change which sheave the belt was in. The very slow was patented in 1954 and the Slo-Speed converter was patented in 1955. Shortly after both of these patents were obtained, Savage Manufacturing ran into financial difficulties and was eventually purchased by their landlord, who owned the Gilbert Engineering Company. Even when Savage actually owned the company, most of the components for both devices were being produced by the Gilbert Engineering Company. Concurrently, while both devices were being manufactured and supplied to Craftsman, Savage Manufacturing and later Gilbert Engineering sold them as Savage Manufacturing devices as well. And here you can see a Slo-Speed converter that has the Savage Manufacturing tag on it. Coincidentally, Mr. Pete is currently doing a series of videos on the Slo-Speed converter on his YouTube page, so I will link one of the videos here. So how does this thing work? Well, you've got an opening where you would insert the shaft coming from your motor, and then you would tighten it down with a set screw, and you have two 2.5-inch pulleys there. The outer pulley is going to spin at the whatever RPMs your motor is running at, 1725, but that inner pulley is going to spin at a slower speed, a reduced speed. So you could just move the belt from the outer pulley to the inner pulley when you needed to cut metal, and then move it back to the outer pulley when you're cutting wood or plastic or whatever. So this thing has a clamshell design, and you've got a total of 3 screws to remove to be able to remove the cover. One on each side, and then the bottom screw, which is actually dual purpose. It holds the cover in place, but it also holds the 2 torsion bars that are required, and I don't have, so I'm going to have to fabricate them. And here you can see the clamshell. I really feel like one side of it should have been flared so that it overlapped. It would have had a cleaner finish to it, in my opinion, but it is what it is. And so we're looking at the internals now, and you have a total of 4 pulleys on the inside. And these are cogged pulleys. And using the cogged belt, they actually function more like gears or sprockets than they do pulleys. So, but these 2 sets of cogged pulleys working in parallel is how you get that 10-to-1 ratio once everything is computed. And these are run in parallel. So 1/2 of this is reducing it by, I think, roughly 3.2, and then the other side as well. And when you multiply all of that and do all the crazy math, and Mr. Pete's video explains it a lot better than I could, you end up with a little bit over 10-to-1 ratio. It's like 10 point something. But they just rounded it to 10-to-1. Now you can change out the belts by removing that snap ring and then sliding that smaller pulley off of its shaft. And you can still buy these belts. They're available on eBay for about 25 bucks or so. But that's roughly how this thing works. It's really cool, very rare. If you have an opportunity to come across one, I would definitely recommend snagging it. To fabricate the torsion bars, I'm using a piece of bar stock. It's 1/8 of an inch thick and it's 1 inch wide. And this is a 3-foot piece. Since I don't know what they actually need to be as far as how long, I'm just going to cut 2 pieces out at 12 inches long. So we'll go over to the bandsaw. We'll cut the first one. And then we'll cut the second one. Once I've got those 2 cut, I'm going to tape them together. And then we're going to square the ends on them, clean them up a little. Using my 1x42 belt sander that I love. This is an outstanding belt sander. And then I'm going to trace out the 1 inch circle on one end so I can round it. I'm not trying to make it perfect, but you know, I want it to look halfway decent. So once we've got that all rounded out, we'll mark the center point that we're going to drill, and using a punch, that way the bit doesn't start walking all over the place. We'll take this over to the drill press and drill out the center. And once we've got that drilled, we'll just clean up those ends with a deburring tool. And we're going to go ahead and put the bend on it. And I think it had one bend right at the slow-speed converter, and then another bend where it engages with the motor mount bracket. But I think what I'm going to do is just do both bends here. That way all we've got to do is measure and cut and drill at the motor mount bracket later on. So I have no idea what this angle is supposed to be. So I'm just guesstimating it here, and if it's all wrong, I'll just fabricate new ones. It's not a big deal, but it's not like it's going to have a ton of torque on it. These are just to keep the slow speed converter from rotating when it's attached to the motor. So there you go. After that, we'll remove all that tape. And we'll just set these aside, and we'll worry about cutting them and drilling them to fit once we've got a rebuilt motor and motor mount. So next, I pulled the column out of the citric acid bath and rinsed it off. Then I coated the inside of the column with WD-40. And here I've got my poor man's lathe set up. I go over how to set this thing up more extensively in some of my drill press videos, so I'll link at the top probably the most comprehensive coverage of it. But I'm using a 60 grit or an 80 grit sanding wheel on my angle grinder. And then I go to dry sanding, where I'll go from 80 to 100 to 120, 180, 220, all the way to 320. And then I wet sand with 320 all the way up to 1,000. So 320, 400, 600, and then 800, and then 1,000. And with the wet sanding, I'll go about 10 inches, and then I'll re-wet the sandpaper and then continue. I go all the way down the length of the column, and then I come back. And that's one pass, and then I'll clean off the column and change the sandpaper to the next grit that I'm going to use. But like I said, in the linked video, it'll have a much more comprehensive discussion on how I do this. And there's the 1,000 grit. So once that's done, we clean off the column and then dry it off, and then we're going to apply the Meguiar's mag and aluminum polish. You can get that at AutoZone or any of your auto parts stores. And we'll just apply the polish, and then we'll buff it off. I'm using, I think they're sham wows or whatever. I cut them into strips and use them. And then we come back and apply a coat of Johnson's paste wax, which I have been told Johnson's is no longer making, so really any paste wax would work fine. All it's doing is protecting the metal to keep it from rusting. And I recoat my columns on just about everything about once a year. Living in Georgia with extremely high humidity in the summertime, my stuff would rust in a heartbeat if I didn't coat it. So it all gets coated. And then we just buff that wax. And once that's done, we'll just set that column aside. Here we are with the table, and as you can see, it is really pitted, and this has already been degreased in the simple green, and then it was in the citric acid bath for derusting, but there's still a good amount of pitted rust on there. So I've sprayed it down with some WD-40, and I have 80 grit sandpaper on my sander, and we're going to just sand this thing, make 2 passes in each direction. And then move it up an inch or so, and then do another 2 passes, and then go up another inch and do 2 more passes, and then we'll go forward and backwards 2 passes, move it an inch, so on and so forth. So I end up going through this process 3 times, but I wanted to show you how I go through one whole process here. And once I've finished this first phase of sanding, I guess you would call it, I'm going to clean off the table, and then I will switch out that pad with a new pad on the sander, and then do the whole thing again, like I said, 3 times, and that got it pretty well cleaned up. But you'll see what it looks like with just this first one once I wipe it down. So that's already a really big improvement. So 2 more like that, and we got it where we felt like we could go ahead and continue with the sanding. So after we cleaned it the 3rd time, then we just went to straight dry sanding, and I used 80, then 100 grit, then 120, 180, 220, and then 320, and I stopped at 320. And this is 320 here. And after that, I cleaned up the table with some mineral spirits and then set it aside. And the next time we do anything with this, it will be to mask it for painting. So that's going to wrap up this video. I hope you found it helpful, and I hope you enjoyed it. If you did, please like and subscribe. In the next video, we'll be wire wheeling a lot of the parts and cleaning them up. So thank you, and I will see you next time.